All right, good morning, everybody. Hope you guys are doing well. Today I'm going to go over half of section four. So, section four is pretty jam packed with a lot of information, mostly of which you went over in Algebra 2. So, I'm actually going to break up section four into two parts. That way, we can take it a little bit slower. That way, if you're struggling a little bit with this, we'll have time for me to be able to help you during our live sessions. So, what I'm going to talk about today in the first part of section four is what a standard form of an equation, a quadratic equation is um, first. So let's start by that. So as you can see right up here, it says standard form of a quadratic equation is ax squared plus bx plus c equals 0. So to give you an example of that, you could have something like 2x squared plus 4x minus 5 equals 0. What I want you to see is a couple things in this. Notice that we start with the highest power of the variable, so that's an x squared, followed by an x to the first, and then we have the constant. So that's the main thing that you need to understand about quadratic, standard form of a quadratic equation is that it goes and it orders the variable degrees from highest to lowest and that the equation is equal to 0. So everything is moved over to one side of the equation. So in this first example problem, you can see we have this 4x equals 2 minus 3x squared, and the directions say write the following quadratic equations in standard form and then identify A, B, and C. So what you want to do is you want to move everything to the left-hand side. So if you look and see what they did there, the first step is they added 3x squared to both sides. Now, by adding 3x squared to both sides, it's going to eliminate this minus 3x squared right there. And so we will be left with 3x squared plus 4x on the left-hand side, and now there's only a 2 on the right. Now, after we did that first step, now they're going to subtract 2 from both sides, which you can see right there, and that is going to cancel out these two twos, and it'll leave us with a 0 on the right hand side, which is what we want. Now also notice that as we're moving these pieces from the right over to the left, so as we move this over here and then as we move this over here in the second step, they're ordering them. They're putting them in the correct order. So you can see we have the 3x squared first, then we have the x to the first power, and then we have the constant, and it's equal to 0. So this part right here is our final answer. That is standard form of a quadratic equation. So it's 3x squared plus 4x minus 2 equals 0. Now, they did ask us to identify A, B, and C in this, and once you have it ordered, it's really easy to identify A, B, and C. A will always be the first one, B will always be the second one, and C will always be the third one. Now, one thing to keep in mind, if you have a quadratic equation that might be like negative 4x squared minus 5 equals 0, this does not have three terms. So what I said in the last one, A is the first one, B is the second one, C is the third one. That is true if you have all three terms. Now in this case, we don't. So the A term is going to be what's on x squared. The B term is what is on x. But in this case, there is no x term here in the middle. So when you would write this out, you would write A equals negative 4, but then you would write B equals 0. And then, of course, C is the constant term, the one that does not have a variable by itself. So you can see, let me move that out of the way here, move myself here a little bit. You can see C is negative 5. All right, so that covers that. The first few problems, it says write the following quadratic equations in standard form, identify A, B, and C is exactly what I just showed you. The second part, they give you some examples on how to factor. I'm going to skip those until the next video because I am breaking this up into two parts. So I don't want you to do any factoring per se, other than to factor out a common factor, which I'm going to show you how to do, and then I'm going to show you how to FOIL, and then you're going to stop at number 12. So you guys are going to do 1 through 12 for tonight, and then the next video I'm going to go over factoring, and I want that to be by itself. So let's talk about real quick how to factor out a GCF. Um, if I were to take a GCF, if you remember, GCF stands for greatest common factor. So for instance, if I give you an example, if I had a 6x to the third minus 4x squared plus x minus 2, let's make this a 4x. So 6x to the third minus 4x squared plus 4x minus 2. What you have to do is you have to go through and look at each individual term within the expression and determine first, is there a greatest common factor as far as number goes? You can see we have 6, 4, 4, and 2. Those are all divisible by 2, so we are going to take a 2 out. The next thing we're going to do, and actually I'm going to modify this equation just a little bit. I want to take this minus 2 off. The 2 still holds true, though. We can take a 2 out of a 6 and we can take a 2 out of a 4. The next thing that you have to do is look at this expression and determine what is the most amount of variables that I can take out of each of them. What do they all have in common? And you can see the first one has x to the third, the second one has x to the second, and the third one has just one single x. So what that means is the most amount that you can take out of all of those that's the same is one single x. So I'm going to take a single x out of all that expression too. Now what am I left with? So now that I've determined that the greatest common factor is 2x, and we've taken that 2x out, we need to write what is left. So 6 divided by 2 is 3. X cubed divided by x is x squared. And now we're going to take this 2x and it's going to divide this, it's going to divide this, and it's going to divide this because we pulled it out of those. So 2x negative 4 divided by 2 is negative 2. X squared divided by x is x. So we took this first term 2x, we divided the 6x to the third by 2x. Now I just divided negative 4x squared by 2x. Lastly, I'm going to divide the 4x by the 2x. So 4 divided by 2 is 2, and x divided by x is 1, so that's that. And we leave it just like this. Now, looking at this expression, this might be a little bit tricky. I'm going to rewrite this. See if I can erase this without messing it all up. So this will make sense to you more. All right, so we have a 2x right here. All right, so looking at my new expression, I have factored out the greatest common factor, which is 2x. If I wanted to double check that I did this correctly, if I would redistribute this to all three things, I will get the original equation up here. So again, these are two steps. You got to determine what's the biggest number that will come out all the numbers, and then what's the most amount of variable that will come out of each of those equally. And then you could write your GCF, which is your 2x. So that's an example of what you're going to be doing for number 7 and number 8, where it says factor out the common factor out of each expression. Now the last one tells you to expand, and I said hint, FOIL. So just remember, if you have an expression like x minus 3 squared, you cannot just distribute that square and make it x squared minus 9. Doesn't work like that. When you square something, it means you have to multiply it by itself. So the first thing you want to do is expand this out and then FOIL, which is first, outer, inner, and then last. So x times x is x squared, x times minus 3 is negative 3x. Then we're going to go to the inner, negative 3 times x is negative 3x, and then last, negative 3 times negative 3 is 9. And then from there, we're going to combine our like terms. The like terms should always appear in the center. And there's our final answer, x squared plus 6x plus 9. So that's what you'll be doing for the 9 through 12. And I want you guys to stop after 12. And like I said, in the next section 4 video, I will go over the factoring part. So, all right, guys, hope that made sense. Have a good day.